Feeling lost in the world of machine learning? You're not alone. It can seem overwhelming, but it doesn't have to be. In this video, I'll break down the key algorithms in a simple, easy to understand way, even if you're a complete beginner. We'll explore essential algorithms like linear and logistic regression, k-nearest neighbors, support vector machines, decision trees, random forests, boosting, naive Bayes, k-means clustering, principal component analysis or PCA, and even get a glimpse into neural networks. By the end, you'll have a solid foundation for understanding how these algorithms work and which ones to choose for your projects. Imagine you're trying to predict house prices. Which algorithm would be best? Or perhaps you're building a spam filter. What approach should you take? The key is knowing each algorithm's strengths. Let's get started. Linear regression. Need to predict a number, like a sales forecast or temperature reading? Linear regression might be your go-to. Think of plotting points on a graph. Linear regression finds the best fits straight line through those points, showing the relationship between your input, like advertising spend, and your output, sales. It's great for predicting continuous values when there's a linear relationship. The steeper the line, the stronger the relationship. For every dollar spent on ads, sales increases by X amount. What if you're not predicting numbers, but categories? That's where logistic regression comes in handy. Logistic regression helps us classify things. Is this email spam or not? Will the customer click this ad or not? Instead of a line, it uses an S-shaped curve to predict the probability of something belonging to a specific category. It's perfect for situations with two possible outcomes, like yes or no. Next, let's explore k-nearest neighbors, an algorithm that's all about finding similar items. Imagine recommending products to customers. You might suggest items similar to what they've bought before. That's the idea behind k-nearest neighbors. K-nearest neighbors looks at the k, closest data points, to a new data point and classifies it based on the majority category of its neighbors. It's great for finding patterns and grouping similar data, even when the relationships aren't linear. But what if you need to draw a clear boundary between categories? Let's talk about support vector machines. Support vector machines, or SVMs, are like expert line drawers, creating the perfect boundaries to classify your data. They find the best line, or hyperplane, that maximizes the separation between different categories. SVMs are powerful for complex data and drawing clear distinctions between categories. Now, let's explore decision trees, a more visual way to classify data. Ever played 20 questions? Decision trees work similarly, using a series of questions to classify data. They branch out based on different criteria, leading to different categories. Think of it as a flowchart for your data, easy to understand and visualize. They help make decisions based on clear rules. Let's see how combining multiple trees creates even more powerful algorithms. Random forests and boosting. Imagine getting predictions from a whole committee of experts. That's the power of random forests and boosting. Random forests uses multiple decision trees, combining their predictions for increased accuracy. Boosting sequentially improves models, learning from past mistakes. These ensemble methods are great for handling complex data and improving prediction accuracy. Next up, naive Bayes, a simple yet powerful algorithm for classification. Want to build a spam filter? Naive Bayes is a classical choice for text classification. It uses probability to determine the likelihood of something belonging to a category based on its features. It assumes features are independent, hence naive. Simple and efficient, it's often used for text classification and spam filtering. Moving on to neural networks, the brains behind much of modern AI. Inspired by the human brain, neural networks are complex but incredibly powerful for learning intricate patterns. They are interconnected layers of nodes, like brain cells, to process information. They learn from data by adjusting the connections between these nodes. Neural networks excel in tasks like image recognition, natural language processing, and other complex tasks, driving many AI breakthroughs. Now, let's look at a couple of unsupervised learning algorithms. First up is k-means clustering. Want to find hidden groups in your data? K-means clustering is your tool. It groups similar data points together into clusters based on their distance from each other. You choose k, the number of clusters you want. It's like automatically sorting your data into meaningful groups, revealing hidden patterns. Finally, let's explore Principal Component Analysis, or PCA. Data can be messy with too many variables. PCA helps simplify things. It reduces the number of variables while keeping the most important information. Think of it as squeezing out the redundancy in your data. PCA helps simplify your data for easier analysis and can even improve the performance of other machine learning algorithms. Well, we've covered a lot. You now have a basic understanding of many powerful algorithms. The key is to choose the algorithm that best suits your specific problem and data. Consider these factors and don't be afraid to experiment. What projects will you create with this newfound knowledge? Share your ideas in the comments below. And for more machine learning content, subscribe and hit the notification bell to get more videos on AI, the future, and business.